Okay, first of all, that's the December webinar, Cloud as 5G Enabler. We have like a series of webinars in the last year. You can find them on YouTube, but we thought of bringing some sort of interesting topic that mixed like two technologies together, the cloud and the 5G. And we will try to assess the cloud from a 5G perspective, not a pure 5G webinar and not a pure cloud webinar. It's a kind of mix. So if this is like your first time to attend the webinar, for myself, my name is Karim. I'm an IT consultant with almost like 17 or 18 years of experience. So my background mainly is from the telecom, from the mobility. So I spent like the majority of my career working on the core networks on the mobile field, and then I shifted somehow to the automation orchestration, and currently I'm a senior architect in Red Hat. And in addition to that, I have some contributions in some open source initiatives and the standard bodies like OpenNFV, XNFV, and GSMA entity and others. And it gives me pleasure really to welcome my friend and my colleague Mohamed Negm. We kind of sharing a very close profile. So both of us, and especially Negm, he spent most of his time of his career working on telecom industry, working in Huawei, on Ericsson, and then I think Negm moved to Germany like I don't know, like many years back, and then you joined Deutsche Telekom, and he's currently a Telco cloud architect at Google. So Negm, welcome. If you want just to say some introduction or some few words before we start.
Thank you for the nice words, and thank you also for getting me the chance to join here as well. So very looking forward to the vibrant discussions in this webinar. So I hope everyone will be happy with the results.
Yeah, hopefully. Thanks, Negm. So yeah, just before we start, please use the Q&A module in the Zoom if you want to post any questions. We will try to stop after each section to get the questions. And any question that's not covered in the webinar, we will take that offline and we'll try to like post it in some sort of post-webinar post on LinkedIn. It's 1 hour webinar. Maybe we can like just go maybe 5 minutes more or less, but we'll try always to keep the 1 hour time frame. So we start with the usual disclaimer and then we move forward. So as I said, me and Negm, we thought that of bringing or assessing the technology of the cloud from the 5G perspectives and vice versa. We are not intending to provide a webinar solely for 5G, talking about core flows, and not solely for cloud, talking about cloud fundamentals. It's a kind of something in the middle, because we believe that this is something has always causing confusion among the community of both cloud professionals and also people coming from mobility and telecom background. So we are going to explain first what is actually unique about 5G, why 5G is different from 4G and 3G, why we have all this hype around 5G. And then we start to list some use cases that explain the interactions between both technology, the cloud and the 5G, and how actually the cloud enables a technology like the 5G. So we are going to assess what are the cloud models and how that's mapped to the 5G architecture. We'll talk specifically about the service-based architecture. And then we will talk about the edge as a 5G use case, and we'll explain the 5G, the cloud role in that. And then we take one of the most trending use cases of the 5G, which is network slicing. We will go quickly on the end-to-end solution, but we will focus on the cloud part because that's the main target of the webinar. And then we will scan the 5G requirements in terms of technical requirements, operational requirements, and even organizational requirements, and how the cloud can adapt to fulfill these requirements. And at the end, we usually, as we did in the last webinars, we end with some market directions to tell you exactly what's happening now on the market. So I believe we can start. So what's unique about the 5G? So the first thing actually about the 5G, and people coming from telecom background, I know they felt that 5G is a very business-oriented evolution of the technology. It's not just some sort of a technology or capabilities boost or technological capabilities boost. Like it's not just like widening the data pipe, making users, consumers to consume more data, which is fine. It is there, but the main target of the 5G, and that was actually clear in this diagram that I'm showing. It's coming from the ITU document, actually the one that opened the door for the 5G. You see that most of the enhancement of the technologies are targeting specific segments of the business. Okay, so that's why we feel that, we believe that 5G is a very business-oriented technology. Most of the monetization, for example, will come from the enterprise segment, and that was not there in the 4G. Yani if people working in the 4G and even 3G and 2G, me and Negm, we worked on that. It was solely focusing on the technology itself. But now with the 5G, whenever you heard these terms of 5G SA or maybe the edge or slicing, this maps to some business use cases. Like these are intended to bring like monetization to the provider or the enterprise. What is also new in the 5G and was not there before, that there is a clear framework for orchestration provided by 3GPP. And that's the main body or the main home of standardization on the telecom domain. So for the first time, 3GPP introduced a clear framework for orchestration. For example, what I'm bringing here, just informative diagram showing what was proposed by 3GPP for the lifecycle management of network slicing, doing the modeling, doing the activation, deactivation, termination, the full lifecycle management. So that was there before in the communities, coming from TM Forum, coming from open source initiatives, coming from ONAP, open source Mano. But for the first time, people working on the telecom and the mobility found themselves in front of an orchestration framework provided by 3GPP. Third thing, and I know that Negm, you were focusing on that on the last years, is actually in the evolution of the architecture. So Negm, if you'd like to take it,
sure.
Floor is yours.
Yeah, so we can also see that change is not only coming from this extra services added on top, but also the architecture evolution itself has been much different from what was happening before the 5G. So in the 2G evolution to 3G and 4G, the evolution of the architecture from the 3GPP point of view was always around new network entities being either introduced or some kind of extra new interfaces, which is shown on the left side, what we call as a reference model, where we have each network element having a specific interface towards specific nodes. And this kind of interface has also some different protocols based on the communication expected there. But on the right side, where the architecture evolved into the service-based architecture, you can see it became much more flat. And the intention behind that is to introduce a service model instead of just network entity model. And in this case, it is also implied by the fact that all the nodes are communicating by the same message bus, which is shown in here. And that also implies that most of the nodes are more or less communicating with the same protocol. And there is no distinction anymore between which node can speak to which other node. So this kind of service mentality brings also the idea that you deal with the 5G not as a new network, core network protocols introduced and so on, but more as one big framework that are exposing some kind of APIs towards the applications running on top, which matches exactly what you were talking about the business cases. So each business case is going to trigger a specific APIs within the 5G to serve a specific business case scenario, such as location-based related or low latency and so on. And in the same time, it also allows the market to expand and have extra service providers which can then fit their services within this 5G as a framework to run network function services. So maybe you can take us as well towards how the market looks like and how there is new entrants as well doing some other type of services instead of the normal networking ones.
Yeah, thanks, Negm. And I agree. I even remember when we knew that the evolution is going to take us into service-based architecture. Like I put a post on LinkedIn that I was very happy that we are going to APIs, because we have always suffered with SS7 and SIGTRAN and even diameter and these kind of things. But when I put the post, the colleagues coming from IT background and coming from software development, they said, yeah, we have been there like many years back. But for us, for the telecom tribe, that was really a huge evolution.
Yeah.
What is also there in the 5G, and you may notice now, because there's a lot of market fragmentation, or many entities influencing the technology. In the old days, like 15 years back or 10 years back, you find that these entities were very limited. So 3GPP would the only one driving the path into technology. Some vendors were contributing, but all were focusing about 5G, about 3GPP. But now what we see in the 5G, that there are a lot of entities influencing the technology, influencing the directions, influencing the way of deployment. So SDOs has for sure it is there. So that's the standardization bodies like 3GPP, it is there. The giant telco vendors are there, and they are doing fine, evolving their portfolio, like Huawei, Ericsson, and Nokia. However, we found that wave also enabled or what the gate for many startups and new players to enter the game. So there are a lot of startups now, a lot of new players in the market offering full 5G in a box, 5G for enterprises, private 5G. They are really doing well, but now we see them. That was not the case at all in the 4G. Cloud providers and hyperscalers, we see now how 5G news are very coupled with press releases coming from Microsoft, from Google, from AWS, and even from Alibaba. So now there are a lot of hype also, or a lot of news coming from these segment of in the market, because of also you have a lot of open source components, a lot of directions. So that brings the necessity of having system integrators. So system integrators now, they have also good presence in the 5G market share, like Tech Mahindra, NEC also doing a good system integration. If you take the model of RCP and see what they are doing for Rakuten, for other operators, that's some sort of a system integrator. So there are a lot of now of key players, and that's somehow, I always say that whenever you have a standard, a reference, and it is only unified, that will speed up the adoption of the technology, because you know the reference. But when you get multiple directions and multiple messages that sometimes it might look contradicted, this somehow slow the adoption. I hope this does not happen in 5G, but that's the case currently in the market. One also of the most confusing, I would say, subjects or topics about 5G, that there are a lot of coupled technologies, a lot of buzzwords, a lot of like trendy words you always hear when you hear 5G. So I'm not sure actually does this belong to 5G, yes or no. I will just pick one, and I will tell you what was the case exactly when we had this kind of coupling. For example, containers and cloud native. With 5G, we had the impression in the market or the community, telecom community, that 5G, it's all about containers, which is somehow we can say it is true. However, we see that actually some vendors and some players in the market, they started to have, for example, the UPF VM based. It was VM based, and we saw that. So it was not 100% coupled by deploying the 5G on a certain cloud technology or a certain service, but it is somehow coupled in a way or another. The cloud native, they say, okay, 5G is a cloud native deployment. However, cloud native, and for example, Negm will explain that there is an architecture or there's a framework for cloud native. It's not necessarily followed 100% by many vendors in the market. Okay, so there are a lot of technologies, a lot of buzzwords around 5G, and that again cause confusion. That was not the case at all in the 4G. We were very focusing on the technology. Other things are very coupled with 4G, was very clear, well defined. Like for example, voice over LTE, other services are all built on 4G. So that was just the introduction. Why 5G is different, and that's, we will also give an introduction about cloud, and then we will talk about the interlocks between both technologies.
So maybe before we move, there are a couple of questions on the Q&A.
Okay, let's pick one.
Okay, I can pick one. So I see the first one, for example, is Orchestration is trying to streamline and optimize frequent and repeatable processes. So what kind of repeatable processes or time to market we want to reach in the 5G? Because this point is still not clear. And take a slicing as, is orchestration destined to provision it? And do we have to provision many slices to put in place orchestration?
Okay. Negm, would you like to take that or shall I take?
Yeah, so I think that the main idea here from having an orchestration within the 5G is not only to do repeatable tasks, but as I mentioned before, we need to look into the new 5G service-based architecture as a common framework to run multiple services inside, network function services, which is going to serve application layer on top of it. So if you look into it from this perspective, that the 5G is some kind of a platform to deliver latency-related functionalities, networking-related functionalities, routing, and so on, you will see that the service orchestrator in this case is more or less trying to ensure that the services are communicating with each other properly in order to deliver the SLAs required for the higher layer applications, such kind of, I don't know, vehicle-to-vehicle communication, for example, and stuff like that. And then the service orchestrator is ensuring that the services and the lifecycle management of the services within the 5G context is running properly in order to serve this purpose. So it doesn't have to be only for the slicing and just managing the slicing, but ensuring the whole vertical is really delivering the SLAs and the business-related service parameters. As simple as this. So
I want to comment on that also, and there's another question about the edge and the startup. So we will answer to that when we come to the edge. But about that point, the problem here was not a problem. That's the orchestration framework was mentioned in 3GPP in the context of slicing. That's why it caused somehow of a tight coupling between both. But I worked on orchestration, for example, for many years. Orchestration is a service agnostic. For example, you cannot say voice over LTE orchestrator. No, orchestrator is an engine that can provide any kind of service, okay, based on the innovation of business people, of the developers. So you can develop or you can deploy any kind of service, not necessarily network slicing. But why slicing in particular? Because it was mentioned in 3GPP in the context of slicing. But again, orchestration is a more generic concept, allow you to give like more services, not necessarily slicing. So we will now proceed. I will respond to the edge point when we go to the edge. Let me just go back to the okay. So the same we did in the cloud. Let's just give a review about the cloud models. And we start to see the interlocks between the two technologies. So from cloud model perspectives, like characteristics and models, we have characteristics, we have service models, and we have deployment models. So the characteristics is actually what are like the features of any deployment that we can call cloud. That was defined by the NIST like a few years back. Like the on-demand self-service, broad network access, resource pooling. I will pick one, not just to waste a lot of time about this slide. For example, the rapid elasticity. Okay, so cloud by nature should be able to scale. Okay, either scale out, scale in, scale up, scale down, according to the workload requirements or to the workload's state. Okay, and that we'll come back to this one because when we go to the cloud mindset. And we will talk about that we shouldn't focus a lot about where our workloads run. We shouldn't focus a lot about having a disaster recovery environment. No, one of the main characteristics of the cloud is the rapid elasticity. So you don't care a lot about how your workloads are deployed because they are scaled up, scaled down according to the usage. For service models, we have the traditional infrastructure as a service. We have container as a service. We have platform as a service, software as a service, function as a service, and anything as a service, right? We started initially with infrastructure as a service, platform as a service, and software as a service. Those were the three main service models. when we go to the telco part, we will understand exactly what's happening on the telco clouds, because not necessarily everything is there currently on telco cloud. On deployment models, I would say in the last 8 years, we have seen the rise of the telco cloud. So it's kind of private cloud that takes care or onboard the telco workloads, in addition to the like the existing well-established and stable IT cloud, which has always been there, carrying the IT applications. But currently, we see a lot of hybrid cloud and multi-cloud approach, where the operators now start to welcome, for example, a public cloud from a certain provider, or even his own public cloud, and start to get a hybrid view of the two clouds, either by unified orchestration layer, or even by collapsing having this unification on the cloud level. So we have seen lately a lot of assessment exercises and strategy exercises about CSPs owning hybrid cloud and multi-cloud. Negm, for me, you in particular, you have worked lately in an operator doing cloud stuff for telco, and then you moved to a cloud provider and software provider. So what is the telcos doing now? Where are we now exactly, and where are we aiming to go?
So if we look into where we were starting 8 years ago, exactly as you mentioned, so we started with the infrastructure as a model, infrastructure as a service model. So where the telco operators and CSPs were providing the infrastructure and then running virtual machines on top of that. And the aim and the goal from this very first step was basically to start softwareization of the infrastructure and the related workloads as well, and separate the software being delivered as a network function from the associated hardware. That was the previous model. And from that started to rise also the similar issues like the ones were there before, because the fact that the virtual machines are still not rigid enough, and most of the vendors can introduce all kinds of dependencies and make beefy machines to allow for more processing and so on, which ended up having really silos still within a cloud environment. And the movement which is currently happening now in the market is to move towards a cloud native, because from the cloud native principles itself, looking into something like the 12-factor apps and all this kind of IT-related microservices approaches and best practices, the main idea is you decouple the service itself from all the centralized and the command-related functionalities, so that the service would really only focus on doing a specific processing of one packet, as that is it, while you can then control and enforce specific other common related application and functions, such as monitoring, tracing, and routing, and so on. And that can be achieved, from my point of view, by including two types of offering, as you mentioned before, where you can have CaaS services, which can then accommodate for all the different requirements coming from the vendors, because each vendor will have some kind of different requirements towards the networking, to the deployment, to maybe the versioning, and so on. And that you can already accommodate with the CaaS offering in your infrastructure. But in the same time, all this kind of common and management-related services, the CSPs can offer this in the form of a PaaS service, which then is going to be enforced to each and every vendor in their own separate CaaS. So that is the main idea of having such kind of change at the moment. And this is also being somehow served by the 5G architecture. So if we look again into the 5G architecture now and how they started to have this mindset of the service-based, you can see that the service-based architecture allows you to embed extra services as you want, as shown by this unnamed service. And as long as you are following the framework more or less, then you can really embed whatever services that you want. And the fact that doing so allows you to inject this kind of platform as a service related offerings that is going to be managed by the CSP, but not by the vendor. And then the vendor can only focus solely on delivering a specific service. And that matching exactly what we have as a microservice architecture best practice. If we look into this lower part, it is more or less like a standard microservice approach where you have your services running in a microservices related container as a service, and then being served by different common management services or API gateway, identity management, service discovery, which would be the same for any CAS being deployed on top. And this kind of commonalities and characteristics are basically coming from all this microservice related architecture best practices, such as having the services working in a producer consumer model so that we don't need to define who would be the producer of the service, who would be the consumer. Anyone could take any of these roles based on the requirement. HTTP APIs all over the way, and in the same time, stateless services where a consumer can subscribe to a producer notification so that it works in a more asynchronous way instead of having this kind of client synchronous methodologies. So that is basically most of the related changes that leads towards what we are now working towards, which is the cloud native role and how can we offer CAS and PaaS services.
Yeah, very, very interesting. But by the way, if you see most of the vendors offering for the 5G, because that actually, I mean, exactly matching what you were saying, that any kind of monitoring service assurance tools are introduced to the operator as a PaaS. So I'm giving you a solution that you can plug, and then you provide PaaS for all your cloud, like this kind of Prometheus and this kind of open source monitoring tools. So it is there in the vendor solution offered as a PaaS.
Yeah, exactly. And I think that comes that the CSPs in this case need to stand up and then at a certain point unify all these kind of services and take the responsibility to deliver that by themselves as well. So,
and by the way, even from organizational point of view, if the cloud department can provide this PaaS unified service for all their internal customers, that would be the best thing.
Exactly.
Now, because you need to provide value to your customers, right? Internal customers, right? It's not just infrastructure as a service, like giving them VMs or infrastructure. No, you need to jump up, as you said, and start to provide PaaS for your clients, which one of them for sure is the 5G team or the 5G core. Yeah. Let me just have a look on the Q&A, and then we can start. Okay, one question, let me take it. Okay, the MEC will discuss it. The question is, it's a question about that vendors, they support their own solution. They don't support any CAS or PaaS from third party vendor. And the vendor name is mentioned, but okay. Let me answer that. So it's not like the old days. I mean, me and Negm are working from right cloud software providers, so we meet with telco vendors, and it's not like the old days. No, now they can be onboarded and even certified on multiple environments and multiple PaaS, Red Hat, on Google, on AWS. I say that from my following the market. I see what's happening, and even my personal experience. So it's not like the old days. The coupling of the full stack or the silos, it is there, but now because at the end, most of the operators are going to unified PaaS, as Negm was saying. So what's happening in reality now, they start to be more flexible, more integrated with other unified PaaS, not necessarily their own stack. Yeah, let me start now. One of the use cases of the 5G that we would like to show and see and highlight the cloud role. Let me just start with a quick introduction about what is edge, and that was a previous webinar, so it's an edge recap. So in the telco environment, there are a lot of terms that you always hear, like near edge, far edge, deep edge, enterprise edge, and device edge, and this is somehow a mapping on what does these terms mean commonly in the telecom community. However, you can find some entities, some professionals using these terms in different meanings, but what I'm saying here is like the most common definition. So near edge, for most of the operators are the next hop after the regional and central DCs. So we have always have our stuff, our RNCs, our core network in the regional and national DCs. And then the one hop after that, which is the aggregation or the OLTs, that's the near edge. And then far edge or deep edge, that's actually when you go to the cell site. Okay, so that's the telco operator borders. And that mile is actually referred to a provider edge or telco edge. That's the telco edge. When you go more aggressive and you start to provide enterprise services like something over UCPE, something like enterprise edge, private 5G in a box, that's what we call an enterprise edge. So you provide a service on a certain infrastructure on a box, on a server to the enterprise, and then you go deeper to a device edge, which is actually like the IoT terminal or the IoT gateway. What is common in all these infrastructures, what's common in all these offerings is the cloud. You need to have a cloud operating system, okay, to first of all onboard the edge applications, to give the same services that you have always given in the regional, like any kind of PaaS services. You need to give it on the edge. So similar for infrastructure service and CAS. So it is there, and that's coming even from my experience working on different types of the edges and my view into the market. So any kind of edge solution includes a thin layer of a cloud operating system. That cloud operating system ideally providing traditionally the infrastructure as a service, which I confess it's not common in the edge, but it is there, and it is requested by the customers to have this kind of layer, providing a hypervisor and the old way we do the onboarding, but also providing CAS to onboard the containers and to provide PaaS, like provide monitoring, SLA reporting, this kind of things, API gateways. And on top of that, it always comes with some sort of certified application. So one of the certified applications is actually the 5G core. So if you see now the coupling between this application and the 5G infrastructure, you see a lot of certification happening between the vendors, telco vendors, and the cloud provider and cloud software providers. A lot of applications CNF certified on GCP, a lot of applications certified on AWS, on OpenShift. There are a lot of coupling, even Microsoft buying Affirmed, so they bring their cloud OS. On top of that, they put Affirmed the Metaswitch. So cloud is there on all edge solutions, and we will raise a question, okay, in the coming slides. So you are going to invest in the edge. That will be a huge capex investment. So what is the best thing to go there? Is it to go a traditional model, to go with hyperscaler, to go on an OpEx model rather than a capex model? This is something that we are going also to assess in the coming slides. One more use case to show or to maximize the role of the cloud after we showed the SPA, we showed the edge, is actually the slicing. Okay, slicing. Let me just give the full picture, and then we will focus on the cloud. So from slicing, what I said that 3GPP has enforced an explicit content talking about 5G orchestration, and somehow that was coupled with the slicing. Okay, so from architecture perspective, 3GPP has suggested the presence of something called CSMF, communication service management function, if I'm not mistaken, and NSMF, network slice management function. And what is here on the right is actually these kind of standard blocks. How do they map to the vendor solution and existing orchestration solution? So you can find all these capabilities embedded on many terms, like either it's a multi-domain orchestrator, slicing manager, end-to-end service orchestration, sometimes embedded in the SOM, service order management, and that's somehow integrated with the BSS, with the marketplace. That's something that the portal that the customer used to purchase the service. And then on each specific domain, there is an NSSMF, network slice subnet management function, in the radio, in the transport, in the core, and commonly that maps to what we will commonly label as a domain orchestrator. But actually, in order to lease such slice, to instantiate, to do termination, stop, pause, auto healing, auto scaling, you need to have the right cloud orchestration layer, okay, which maps to the solutions, you know, offered by the market, by Google, by AWS, by Red Hat, by anything, by Mirantis. A lot of solutions here delivering that and making sure that resources are allocated on demand. So you request a slice, you get a slice. You don't request slice, your resources are gone and given to someone else. So that was the introduction to show where the cloud, and now let's see how the cloud fulfills the network slice requirements. So if we just took this diagram a little bit on the left and start to list the capabilities. So slicing by nature is dynamic. I was working on a provider for orchestration solution on BSS, so I was looking to the business part of it. Okay, so the main ask from the customers would actually always to get some sort of a marketplace where can the enterprise customer can go easily, like similar to what we see in the public cloud user experience, digital experience. You go, you purchase a slice, you set the SLAs that you require, and then you purchase. And once you purchase, the service order goes down, and then the slice is up. But slice at the end is based on some sort of dedicated CNFs, right? It can be a UPF, SMF, AMF. There are multiple flavors, but let's take this part. So you need an engine on the southbound to instantiate this service or the 5G slice, push the configuration, and declare that this service is up or this service is ready to be consumed. So that's the ask from the slicing. And that's actually the cloud characteristics, right? It's on resource demand, it's rapid elasticity. So it is dynamic by nature. If you have a real cloud deployment, then you have this dynamicity that's provided by cloud and provided by having the right CAS engine that can automate the instantiation part, supported and ensured by the paths that give the enterprise a view about what's happening on his slice, about the SLAs, about the monitoring, about the alerts. So cloud fulfills perfectly the dynamic slicing. That's why I was talking with Negm. We were saying that if you search in 3GPP about the word cloud, you will never find it. So there is no explicit mention that slicing should be on cloud. Okay. However, from requirements, it mandates implicitly that the existence of a cloud, and that also covers the CAS, because without a CAS, you cannot build the environment to support this kind of dynamic slices. It's really an interesting topic, and we have a lot of aspects about in this particular subject.
Let me add as well is if you look into how the 3GPP is defining the different roles who are consuming and producing the slice itself. So you will find that they have two major roles, which are exactly as you mentioned before, the communication service provider who is going to consume the slice, and the network operator who owns the infrastructure and then assigning slices to this infrastructure. The fact that these infrastructure components are physical, then the network operator needs somehow to be able to dynamically assign resources between these different types of slices given to different customers from the network operator point of view. And that is where the resource management, for example, comes in place, where the network operator can make at the end, the requirement here is the network operator needs a way to assign these resources in a dynamic way, the physical resources, to the logical defined and created slices. On top of that, the different communication service providers will always have different requirements over time. So today, it could be maybe two specific services are communicating with each other, and then later on, it will be something different, and so on and so on. And this kind of dynamic nature of the offering itself requires also an easy way for the communication service provider to communicate with the networking underneath, which is offered by the network operator, and that brings the intent-based networking. So you don't also want, as a network operator, your customer to get into the details of how to configure a router, how to configure a network, and so on, but in a way that they just express the intent, and then this intent is going to be translated into real network communication happening. And that comes also by nature from any cloud deployment, that is the intent-based networking using SDM, overlays, and orchestration. And on top of that, at the end, both are more or less customers to each other's. And in this case, you would like, as a network operator, to understand how much of your resources are being consumed by a specific slice that belongs to a specific customer, which is a communication service provider. The same applies to the communication service provider who want to always to have visibility on the current usage, the current costs of his usage of the slice. And that also comes by default from any cloud deployment, where you by default have all this kind of usage reporting, observability, and which can then be mapped to an SLA, SLOs, whatever you have. So this kind of specific requirements coming from the CGPP does not really say explicitly that you need a cloud, but implicitly the cloud is already offering all of that. Then there is no need to really look for something else to fulfill such kind of requirement, right? But in the same time, that also brings the question is how easy it is to deploy any network function or any CAS offering or any slicing related network on top of a cloud deployment. So in order to talk about this point, I think we need to define different categories into how easy or difficult it is to adapt the 5G requirements as a whole into a cloud. So the first one, which maybe comes to the mind, is the technical requirements. So how easy it is from a technical point of view. So we can see that there are at least, so there are several for sure hurdles, let's say, or difficulties, but the major four are, from my point of view, the first one is about the acceleration. So if you look into use cases where you need really high bandwidths, user plane functionality with huge amount of data throughput and so on, that is something that needs acceleration in order to serve such kind of use case. And that brings you into using some kind of services such as DBDK, SRUV, and NUMA, CPU pinning, and so on. And this kind of stuff is not coming from a cloud deployment by nature. You need to configure that, you need to maintain that. You need also to understand how this is going to impact your offering after all, and your full end-to-end lifecycle management. The same also applies to the fact that the network functions by default is sitting in top of the cloud, but they are not the end point of the user session, which means they are just doing routing on top of another routing platform. And that brings another question, which is the multi-interface networking, because you would need your service to have maybe multiple interfaces to serve different types of interfaces that is currently still in the standardization. It could be in the future that this is going to also move away to a more microservices approach. But at the moment, Kubernetes, for example, as a CAS offering by default, does not support multi-interfaces for the pods. So you need to maintain that maybe by enhancing the CAS offering by other CNI plugins and so on. Another point which is most of the current realization of the different services are based on a stateful workloads. So the workloads are somehow attached by one way or another to the storage, to the node, to the specific hardware that is being deployed on top. And that makes live migration complex, specifically when you talk about a real fluid and automated environment where you have the workloads that can move east and west or move to any other server easily. That makes things a little bit more difficult, so you need to count for that. Another maybe hurdle that a lot of people don't really think about that much is how that the stickiness of the sessions itself, because when you think about it, you have different services which are holding the user session, which is moving from the UE, for example, to do an authentication on the UDM, but it doesn't go there directly. It has to go by different other nodes in between or different other services. And this kind of fact also adds more difficulty there, because only these services serving the current session before the registration or before the authentication really is done, the network as a whole doesn't have the information about the UE at that point. It doesn't know, the UE is not yet connected to the network to store the information or the state somewhere. And that then implies that most of these services would need at least to cache the current flow from the user for some time until the authentication is done. And that also implies that you need to do maybe some kind of load balancing still, but on a flow-based level, which ends up maybe on having unequal balanced services or unequal utilization in your network. So that also need to be taken into the consideration and understanding how can you operate something like that. Which bring us to another topic, which is the operation and operational requirements. So once you have your network already there are also some other requirements from operational point of view, because it is not anymore that you are just deploying cabinets next to each other and then following the normal integration coming from the standardization, standardized interfaces from the 3GPP, but you started now to integrate between some software components in a CAS and some others offered by a PaaS service and so on. So you moved into a software integration company, more or less, or a software integration set of skills that is needed. Another thing is, it is not also just about delivering some CAS and infrastructure, as we mentioned before, but you need to add extra resources to ease your operation, maybe save time, be able to reach the market faster, and that comes with the extra value-added services, which will be offered by the CSPs in the form of PaaS offerings, and how much the CSPs shall really offer there and maintain. And that also brings another topic, which is usually also brought up when the CSP is talking about the operation of the network, is how can we monitor that? So before we were always used to really such kind of this physical taps being tapped into the cabinets and so on. And when you move to a cloud native approach, or maybe even with the normal virtualization approach, it was already hard, but with the cloud native approach, it is even harder because the network is fluid. Most of the traffic is now by default encrypted. So physical taps doesn't really give that much value in tracing. Maybe it's still with the understanding or the intrusion detection system, security of patterns of traffic and so on, but not with tracing or active testing like before. So you need also to move into more software-related security functions and agents that maybe can be deployed next to the workloads and so on. The last point from these major points on the operational requirements as well, when we look into slicing concepts or private 5G use cases, we also understand that in the form that the operators or CSPs or whoever is going to offer that will offer isolated running piece of the network to another enterprise. And this other enterprise or other consumer maybe doesn't have any information about how a mobile network runs. And in this case, it is a must that there is some kind of simple way, simple APIs, and which can introduce exposure of the current network components to be able to configure it without really having to know all the details about the 5G services, SMF, networking, slicing, and so on. Just a very simple interfaces, just a very simple APIs that can abstract the whole 5G as a service or as a platform, but in the same time be able to really deliver the service required by the enterprise or the end consumer. The other set that maybe we can look at as well is, as you mentioned during your discussion before, is the part with the organizational changes and how can this change as well. So maybe you can shed some lights here, Karim.
Yeah, sure. Thanks, Negm. And we got a question about that ICT people, they don't have the software skills, and software people, they don't have the telecom background. So just before I go through this slide, just a short story, okay? It's me and Negm and even one of our friends. We started in Telco. I mean, I worked in Huawei, Negm worked in Huawei. We worked on the core network. Negm, you're in the packet core, right?
Yeah.
And my friend has spent like 15 years in Ericsson doing IMS. And then I'm working now on the Red Hat solution architect, and Negm is in Google, and my other friend is in AWS. So the gap now is being reduced because people of the ICT, with these kind of technologies, you start to realize that technologies are emerging, and you need to get out of your technical comfort zone, start to learn some other stuff that actually backing your business at the end. I mean, you are not just working on software development for sake of software development, but you work, for example, on something that you know that it backs your job. So what I see now, even in the community and from our colleagues and our community, that most of people are started learning the cloud, getting Google certificates, AWS certificates, formerly OpenStack, Kubernetes, and then you'll find a lot of people coming from ICT are starting to get into the cloud, and that's my personal I would say experience, and I think Negm is the same, and many other colleagues are the same. So now everything is emerging, and we need individually to make sure that we are catching this kind of hype happening. So yeah, I'll just go to this organizational requirement because it is very important. The cloud business case, for example, we talked about the edge, right? And if you go to the edge and start providing edge services, most probably you need to invest on a lot of POPs, edge POPs, with cloud infrastructure like scattered hundreds, maybe thousands, according to the nation geography. So there should be a real business case done to decide the strategy. Are we go with a capex model, like we build the infrastructure and then we aim for monetization the same way CSP used to get? Or, for example, we go for a partnership model with a hyperscaler or the partner and go with the OpEx model. We sell together, we win together, we lose together, and we shift our business to the OpEx model. So that's important, because if you started with a capex model and then you don't have a real justification on why you are doing that, most probably you will not take the buy-in from stakeholders, and most probably the whole thing will stop. So this is important. The cloud mindset, that's something that we see as a main challenge while working, because operations team still think of the way we used to manage our legacy stuff in the old days, and that's 100% well understood and respected. But not everything can work with cloud. For example, you don't push the vendors to give you a disaster recovery solution, like a standby DC doesn't do anything. It doesn't make any sense, right? Because the cloud had the right capabilities to protect your workloads and ensure that there is minimum interruption for service, or even there is a full continuity of services while doing change. So this is one of the aspects, but it is an important. Last thing, and that's what's happening on the CSP, that most of the teams are silos. And if you see a service like network slicing, it required the cooperation most probably from the OS people, from the core, from transport, from radio, from the cloud infrastructure, from the cloud orchestration. So it's in order to provide a service to the market, you need the cooperation of all these guys with the business at the end. So this, if you do this with a silo approach, that everyone is working on waterfall and giving handover to the other teams and get approval, these kind of things, this will never work. You need to automate service delivery and ensure that it is released to the market in the least time to market, right? So what we see, that it makes more sense to have more horizontal alignments. You have like a task force, horizontal task force, a team that can work horizontally across the organization. If not aggressively, we go for a full DevOps model, and we have like the full individuals doing different values on the value chain of the service, right? So this is something that we as telecom community, we need to work on to make sure that we are, I would say, keeping the momentum of such cloud native deployments. We need also to change from organization perspectives. I will, there was some, this is the last slide, but there was some questions about the edge. I'm sorry, I forgot that, but so I have to reply about it. Is actually a very good question. So he's saying that there are new startups deploying 5G slicing orchestration and MEC solutions, okay? And there are already big players in the market like GCP and AWS. And I add also, there are also the telco vendors, right? Providing siloed solution or edge solution. So what is actually what's happening in the market, and what are the opportunities for these players? So simply what we see in the market, that most of the edge stuff that being held on, it's more like partnership. For example, it's not a legacy, it's traditional RFP. The CSP gets an RFP and awarded to someone. No, the CSPs now tends to have more partnership with more partners, getting a hyperscaler, getting a startup, getting a telco vendor, whatever. We will go to the market together. If we sell together, we win together. If not, we don't lose a lot, because it's not a capex model. So this is what I personally see and what I have experience with, and even in the region, in the Middle East. So the intention is not to couple all your focus with one. No, it's actually going to more like partners, having more partners, having more solutions, and then it's like the digital experience you have from marketplace. If the enterprise customer wants a solution from vendor X or vendor Y, or vendor Z, he just clicks on vendor X, and then in a ZTP, zero touch provision manner, the edge solution is built up and the value is provided to the enterprise customer. So it's a good ecosystem that all players can now have value and can influence and can get revenue. I'm not sure, Negm, do you want to comment on that or?
No, but actually there is another question that I wanted just to touch upon, because the answer will be a bit long. It is about that currently the network operators are using, if they are using cloud for spinning CNFs and VNFs, what would happen to the current legacy network operators? I don't see that as it will disappear or something, because even from the standardization point of view, they add even extra types of players within the whole slicing. So you see something like data center infrastructure provider underneath the network operator. So the network operator could actually be working with data center providers in a, let's say, standardized manner. And you see also vendor infrastructure provider, virtualized infrastructure provider, and so on. So the idea from that is to open the market as much as possible. But that doesn't mean that you're going to remove one or another or replace it. Because at the end, a network operator could be having his own assets, and that could also apply to the radios and so on, which maybe the cloud providers would not ever have. And at the same time, it could also span the slice from two different network operators. It could end up actually of having one network operator only slicing the radio part, while the communication service provider is dealing with different network operators, one for the radio, one for the core, and so on. So that is the goal, that is the ultimate goal. It is still so far behind, I have to admit, from that is where the industry is trying to move forward, and also open the market for other use cases. Imagine all kinds of things like unlicensed spectrums and so on, which will allow a lot of other private networks, but it doesn't have to be running on the consumer market as well. So that is just my comment on that.
Thank you, Negm. Yeah, we keep on getting questions. So guys, sorry, any questions that we couldn't answer because of the time, we will answer that offline, and we will like have this kind of discussion offline. So we end up with that market directions. We always we always want to end with this one, because it shows actually what's happening on reality, what's happening on the ground. So for the 5G deployments and how the cloud is positioned, we have three main tracks that we see in the market. So we have the full stack supplier, and that's like full stack, like not the full stack of software, like full stack, like starting from the applications, the infrastructure, the cloud operating system, any kind of PaaS service. So we see that in the market because there are many operators dealing with one vendor, and they have always been doing that, and they continue doing that, and that's fine because it matches their strategy and their goals. So we see a full stack coming from a certain telco vendor, for example, and it's happening on multiple operators, for example, in Europe. But I would say this is not the case in any kind of tier one operators, because that's somehow considered a little bit of vendor lock. And vendor lock, I will not talk into details, but the cost of migration is really very painful and very high if you intend to migrate this stack to another kind of deployment. What we see also in the market, and it is happening because of the richness of the 5G ecosystem, so you end up with a lot of components, I would say, from different vendors. One of my colleagues here mentioned the O-RAN. So the O-RAN, you can get like the RU from vendor, right? CUDU from another vendor, and even another vendor doing the cloud of the O-RAN instead, and the 5G core can be from another vendor, and control plane of 5G core can be other vendor, automation can be from other vendor. So we see that in the market. It's a mix and match a la carte model. So in that case, most of the operators deal with system integrators, like the one I would say responsible to bring that up. And that system integrator also, he may have his own offering. that he wants to replicate. And I mentioned the example of Rakuten, the RCP, right? The RCP, I'm not talking about what's happening in Japan, but what Rakuten intends to do, for example, in Germany and in their upcoming deals that they may announce, that they want to replicate what they did in Japan to other operators and positioning themselves as a system integrator. So both flavors exist. And the third one that's actually very trending, and we keep on listening to the news and hearing that a lot, it's about CSPs partnering with hyperscalers. Initially, the focus was on the edge. You always hear the term edge 5G hyperscaler. So that's kind of partnership that we always see, for example, Verizon, AWS, and also we started first to see news like, for example, Google is there in Saudi Arabia with Aramco. So there are some momentum toward that direction. But also we have seen lately something like AT&T, like T1 operator going with Microsoft. So that's a very trending approach, and it is actually being evaluated, also always examined by most of the operators, even here in the Middle East region. So we try to put like the main three streams. Negm, do you want to comment on that? Do you have any other comments or?
Not really. So you have captured the main three categories, I would say. But the one last thing to point out as well is it is not that only one can be picked, right? So at the end, as a CSP, you could really divide your network into some subdomains. It depends on the strategy of the CSP. Like maybe for the radio, I will go, or for the O-RAN deployment, I would go for a full stack supplier. Maybe for the 5G core, I would maybe, I don't know, rely on system integrator for delivering different components. And then for something like an enterprise edge or private networks or something like that, I could partner with a hyperscaler. So you could end up having in your CSP a mix and match as well from all the three based on the use case, because that brings us again to the very beginning where there are different verticals which are driving the 5G adoption. And these different verticals may have better or worse business case from the telco perspective or from the CSP perspective, and that then imposes different choices on how this is going to be realized.
Okay. Yeah, I totally agree, and we keep on getting some questions. I'm not sure if we have time to do that or not, because it's already like 10 minutes after the time frame. We have a comment that 5G marathon keeps extending, tiring sometime. Yes, well, I would say that's a very nice thing about that career, that it's continuously evolving. And you have to keep up with the technology. Yeah, technologies are changing, architecture are changing, the way we look to things change, and I see it very good and very interesting for us. I mean, you need always to study to keep your profile sharp, right? To cope with what's happening in the technology. So yes, 5G is not an exception. Okay, so with this slide, we come to the end of the webinar. Sorry, we took like 9 minutes out of your time. I know it's a weekend, so yeah. I hope it was informative, and please feel free to share the feedback, any kind of questions. We actually record the Q&A box, so we will just post the questions and the answers. Negm, thanks a lot.
Thank you for having me here. So it was really interesting and nice discussion.
Yeah. Let's do that one more time, inshallah.
Sure.
Thanks, colleagues, for attending, and hope to see you again in the next webinar. Thank you.
Ciao.
Bye-bye.